Go Birds.
Mr. Kirk was about to start this lesson without recording the video, y'all. You were almost deprived.
You know, fun fact, the first video lesson I ever did, and I'm talking like end of March, maybe beginning of April of 2020, forgot to record the entire thing. I had it all set up. I had all the tech. I clicked the record button. I swear I clicked the record button. I got to the end 30 minutes later, and I realized that there was nothing there, and I was really sad.
Okay. I feel like that's worse, but actually I don't know if that's worse or better. The first time I tried to record a video, I only recorded the visual and none of my audio. So then I was like, oh, well, but like I already did it. So like maybe I can just like narrate over it. And it was a disaster. It took so much longer than just doing it again. So
narrating,
I don't know.
Some of my favorite, YouTube, this is a great icebreaker. What is your favorite YouTube chef? Is that like a, does everyone have their favorite YouTube chef? Mine's Chef John.
Okay.
And
I like Doña Angela. She's great.
I'll have to check that out.
Yeah.
Chef
They're
John's
all in Spanish though. So that's,
YouTube has translation, doesn't it?
Sure.
So I can like read, or at least I can look at English subtitles maybe while I listen to it. That might help me learn Spanish.
There you go.
Chef John's signature is a little bit of cayenne in almost everything. Not everything, but pretty much a lot of the stuff he makes, he goes a little dash of a cayenne. But that's I forget where I was going with this. Oh yeah, he narrates over his videos of making food. I think it works a little bit better for food than math though. Okay, you ready for this?
I guess so.
Let's do this. All right, share screen. Oh, by the way, we're wearing Eagles gear because it is not to toot our own horns, but it is Teacher Appreciation Week, and we were permitted to appreciate us. We were permitted to wear. I guess permitted is the right word, right?
We were encouraged to show school spirit this week, and so there's a different theme every day. Today is Sports Day.
It's basically Teacher Spirit Week. Yeah. Then I live for that. I live for anything spirit related. All right, let's get started with some math. Today, we're actually going to be closing out our vector unit, and I promise you vectors will make their appearance again in the future. There's so much you can do with them. But we're just getting the basics here, and we are finishing with the cross product. Not the dot product, the cross product. Yeah. Question for you. This is Contreras. Today's lesson is the cross product. Tell me what you remember about the dot product.
It results in a scalar, but it is with two vectors, and you component-wise multiply and then add together those products. And it has to do with cosine. Yeah.
What are some fun facts about like the dot product being certain values?
Well, if the dot product is 0, that means that your two vectors are perpendicular, because the cosine of perpendicular, which is pi over 3 or 90 degrees, is going to give you a 0. So that's nice. But I guess if it's non-zero, then you don't have perpendicular.
And if it's non-zero, you don't necessarily know much. At least not as much as that 0, that like powerful 0 telling you it's perpendicular. There's one other thing that I want you to remind me about when it comes to the dot product, and that's what it means in a physical context. Do you remember what we used it for?
It had to do with physics. What was it? Work?
Yeah, it was work, right? Because the two things that comprise work are two vector quantities, right? Force and displacement. Force and displacement, vector quantities, and you are calculating work when you look at UV cosine theta, right? We're not going to dig too much into the work application of the cross product, but it does have a physical application. And we are going to define this new thing, the cross product. We'll read through this paragraph in a second, but just if you look down here, VW sine theta, that is torque. So the cross product, its magnitude is going to be, in this case, V. I don't know why it's V and W and not U and V like we've been using, but doesn't matter, arbitrary. VW sine theta is, if you remember, torque in physics. So that is an application of the cross product physically.
Is that that's the right-hand rule thing, right?
Ooh.
The direction of the things, and that's where the force thingy's going.
Yeah, we're gonna be getting some right-hand rule in this video. So
all right, cool.
Throwback
the
to
cobwebs.
the fall when you did the right-hand rule with if you are watching this and Mr. Schaefer still teaches at the school with Mr. Schaefer. I don't know. I have this like
this is weird.
Dream.
This is getting weird.
Anyways, this is a way too long intro. All right. Would you do us the kind favor of reading this paragraph for us?
Yes. Unlike the dot product, the cross product is two vectors. The cross product of two vectors is a vector. The cross product of two vectors is the vector that is perpendicular to the plane containing the two vectors. Therefore, the cross product of two vectors is perpendicular to both vectors. To find the cross product, wait, should I keep going?
Well, I just drew a little picture.
Cool.
On the screen. Do you see that?
Yeah,
I have
super normal.
I have I have A, I have B, and I have A cross B. It is perpendicular to the two vectors. So if you give yourself two vectors, they are contained in a plane. The cross product will be defined to be the vector perpendicular to those. And actually, let me do something in my head real quick. I actually might have this wrong, because if it follows this right-hand rule, I believe that vector should be pointing down. Yeah. This is actually B cross A, but we'll get to that in a second. This is neither here nor there.
Oh, because you're going from B to where A's direction is, and then the cross product.
Yeah, but we'll get to that. If that doesn't make any sense to the viewer, it will in the next 5 minutes. Continue.
To find the cross product of A and B, written as A cross B, we will multiply each component of the first vector with all three components of the second vector, which is the distributive property. We cannot assume that this operation is commutative, so we will act as if order matters.
All right.
Yeah. Should I continue?
Yeah.
Let's define a few basic properties of the cross product. The cross product follows the right-hand rule. I guess right-hand. I don't know. And the magnitude of V cross W equals the magnitude of V times the magnitude of W times sine of theta, which I guess is the angle between our two vectors V and W.
Yeah. All right, so we have the cross product. It follows the right-hand rule, and it has that's kind of our definition. Its magnitude is this thing, torque. This is defined physically. And then it follows the right-hand rule. So it's going to be a little bit difficult to find the cross product of any two vectors. But using these two bullet points, let's find the cross product of some easy vectors. I cross J, J cross I cross K, K cross I. We do care about order, and we'll see why in a second. Before we begin, let me draw us a
nice.
What would I call this? A coordinate space?
R3?
R3? Yeah, let me go ahead and draw us R3. If you guys remember from the previous video. I think that's a valid thing to call what I've just drawn, R3. And then on this R3, I am going to draw three vectors. And I really want blue for some reason, so give me a second to get blue. Let's go with that blue. That's a really nice blue. Ooh, let me close that. All right, so we have this vector. What vector is that?
That's I.
Let's say that's 1 unit.
Okay.
I never actually specified that was 1 unit, but that's going to be 1 unit. All right, what vector is this?
That's going to be J.
J. And I'm better than this. Let me get my little vector hats.
Oh, nice.
And then what vector is this?
In the Z direction, that's going to be K.
Okay, sweet. All right. So the right-hand rule says, take your hand, and there's actually 2 ways to do it. Mrs. Contreras, let me know if you do it a different way. I'm going to do it this way. Do you do it this way or a different way?
I do this way.
Awesome.
Like
Actually, I do it the way you do it, but this is the way that they were introduced to it in physics.
Okay.
So you take your pointer finger and you point in the direction of the first vector. So in this case, it's I. So kind of like pointing the direction of I. Right. Then
Pointing at yourself. Ah, that's funny.
Yeah. That was funny. I'm really happy about that. I didn't. All right. Then you take your second, you take your middle finger and you point in the direction of the second vector. Okay, so it might be an acute angle. It might be an obtuse angle. It might be a right angle. In this case, what is it?
Right angle.
It's right angle, right? It's between I and J, right? So you're pointing at I, you're pointing the direction of J, and then I want you to point your thumb in the only direction that it can go, perpendicular to the two vectors.
Boom.
Boom, up. Sweet. So we now know the direction of I cross J. We don't know its magnitude yet, but we do know its direction because the cross product follows the right-hand rule. Take your pointer finger, point in the direction of the first vector, take your middle finger, point in the direction of the second vector, and your thumb will point in the direction of the resulting vector. So we have the direction. What is its magnitude?
Well, we can figure that out using the magnitude of I and J times sine of theta.
Mm-hmm. So I's magnitude is
1.
1. J's magnitude is
1.
And then what is the angle between them?
90.
And what sine of 90 is?
1.
What's 1 times 1 times 1?
7.
I was ready to give you a round of applause. I had my joke ready. You
1. It's 1.
foiled again. 1 times 1 times 1 is 1. So 1K, I'm just going to write K.
Okay.
Was that a pun?
Yep.
There's too much puns happening. Pun is the
Because you said that this was like a short lesson, so I gotta stretch it out.
Well, hopefully it doesn't be short because it might end up being long. All right, let's do Jai.
Are you okay?
I was really tired 15 minutes ago, and I'm really
Mhm.
glad you gave me the energy I need. Okay,
Woo.
J cross I.
J cross I. So you say to use your first finger to point in the direction of J, second finger to point in the direction of I, and then my thumb's going down. So that means that I have what, negative K?
Negative K. Yeah. Negative, and is the magnitude still just 1?
Yes.
Right. So we had direction matters here. So that negative needs to be there. The magnitude of the vector is 1. 1 times 1 times 1, which is negative K. Cool. All right, we're making progress. Do you want to show people the other right-hand rule?
Absolutely. So I don't like, splitting my fingers up. It's just too much effort. I want math to work if I'm wearing mittens. So if I am for I cross K, I'm going to make my fingers go in the direction of I, and then I'm going to curl them in the direction of K. And then which direction is my thumb going? It is going in negative J.
So I'm going to try to draw. No, I'm not going to try to draw a hand. That is not going to end well.
I'm sure some of our students are probably able to draw some pretty cool hand perspective things.
If someone out there is willing to draw the right hand rule using the curl method, because that is our preferred method, all 6 of these, I, J, J, I, that would be awesome. We could have that little picture for the future. So that'd be sweet.
That'd be a cool journal entry.
And an awesome STEM Arts Night submission next year.
Just got to not lose that file.
All right. So you just said I cross K is negative J, correct?
Mm-hmm.
Cool.
And I think the magnitude is going to be 1 still, because we still have perpendicular lines or vectors, and all of our magnitudes are 1. So we're still doing 1 times 1 times 1.
I like where you're going with. All of these have 90-degree angles between them, so the magnitudes are all going to be 1. Let's jump over to I, KK, and JJ.
Okay.
I don't know why it's not alphabetical. That bothers me. But anyways, what's the angle between them? What's the angle between I and I?
Is that 0?
Just 0. And what's the sign of 0?
Oh, 0.
0. So that's just 0.
0 vector?
I guess.
Because the result has to be a vector.
Mm-hmm.
Yeah.
So the 0 vector, a magnitude of 0 in the direction of, I guess you could kind of put anything, but we'll just put the 0 vector. Is that a thing? I don't know.
It's
I
a
usually
zero
just say
vector.
0. 0, 0, 0.
I think so.
Cool. And then K cross K?
0
0.
vector.
And J cross J?
0.
Yeah, yeah. Boom.
We could
Or
check
so,
with someone else
yeah.
about that.
Yeah, we'll get on that. Okay, K cross I. Now I've got to start thinking again. I'm gonna take my hand, point in the direction of K, which is up.
Mhm.
Now I need to curl in the direction of I, which is towards me. And I'm pointing to the right, which is the positive y-axis. So that's positive J, right?
Mhm.
Right. So we see a pattern. We got K, negative J, J. Notice that
Mm.
it's not commutative, which is, the whole thing up here. We cannot assume that it's commutative. It's not. It's very close to being commutative. The magnitudes are the same. The directions are opposite. All right, J cross K.
So we got J to K. So we got positive I.
And I'm going to go ahead and guess the last one's negative I, but go ahead and prove it to me.
Yeah. So going up for K, around for J. And so we're going towards U, just not in the direction of I. Negative.
Oh, man. Okay. So now we have I guess we could call them the basic cross products. We have done the cross product now. The question is, what do you do when you're given? I'm going to go ahead and rewrite this in the way that some people in class have been preferring. X2, Y2, Z2. What's the cross product between any two vectors? And we're going to do what the paragraph up here said. And it says, we're going to use the distributive property. We're going to multiply the first component by the other three, and then see where we go. So let me do this. X1, Y1, Z1 cross X2, Y2, Z2. What is do you mind if I backtrack? I'm sorry to everyone who really wanted these forms, the component form, but I actually want to take it back. We're going to stay in IJK form.
And I think I know why.
Yeah.
Because you can see the distribution better.
Yeah,
when
I
you're
think
looking at it as a trinomial.
Mm-hmm. All right, so we're going to do x1i plus y1j plus z1k crossed with x2i plus y2j plus z2k. Okay, time for some distribution.
Okay.
What is x1i cross x2i?
Well, we're getting I cross I with some scalars. So would that be 0?
Yeah, it's just 0, right? We got some scalars. We got the x1 and the x2, but those go away when you multiply by the 0 vector. So we actually have the 0 vector. Cool.
And
What
then
is
we have, yeah, x1i times y2j. So I cross j, which I'm going to look back at the table, is k. Can we do that? Is that valid?
Yeah, and I'm actually going to go ahead and just write that. And what are the magnitudes of x1i and y2j? The direction is k. What's the magnitude of x1i?
X1.
X1, right? It's just 1 times the length of x1. So x1. And then what's the length of y2j?
Y2.
Y2. Boom. So we have the 0 vector plus x1, y2k. Let's get the last x1 distribution.
So that's x1, z2, and then I cross j. I cross k is going to be negative j.
Negative j. Okay, so I'm going to go ahead and erase I cross k and replace it with a negative j. And by that, I mean I'm going to put it with the j and then make the coefficient negative. Boom. All right, it's going to get long here. There's going to be 9, 3 times 3. So I'm going to go ahead and jump down to the next row.
Okay.
Ooh. Let's let it finish. Awesome. What is y1j cross x2i?
So j cross I is going to be looking at the table, negative k. So then we get y1, x2, and negative of that.
Oh, sorry, y1, x2. Yep.
y1, x2.
y1, x2, and then a k, j, and I. Yep, cool. Plus.
And this is going to be 0 because we're going to get j cross
j and j. Boom. Johnson
and then,
Johnson.
And then j cross k is.
We got it up here if you want to reference.
I have it in the other thing.
Oh, awesome.
So I'm also not grabbing it right now.
Yeah.
Is positive I. So we get what is that? y1 z2 I.
Sweet. We've got one more row.
Okay, so we got z1 x2, and then k cross I is j.
Okay.
We have z1 y2, and then k cross j is negative I.
Negative I. And what'd you say the magnitude was on that one? Z1, Y2?
Z1, Y2, and then plus our 0 vector.
Boom. Sweet. There we go. That is the cross product of two vectors.
Wow.
If only we had like an algorithm that helped us remember this. This is nasty. Thank you. Thank you for the hats. I'm going to squeeze this a little bit so that we I'm bringing the hats with me. Oh, I didn't mean to ignore your hats.
It's okay. I was hopeful that Kami had changed that, but I guess they didn't.
You want to fix them?
Yeah, I'm working.
Okay, cool. All right, so we got lots of things going on here. What do you think we should do?
Sorry, I'm trying to fix the hats and it's not working because the spacing is different. Okay. Can we like group stuff? Maybe that'll be clearer. Oh, you're grabbing me.
There's a background too. Okay, let's group stuff. We got multiple K's, we got multiple J's, and we got multiple I's.
So x1, y2. Oh, maybe you should put the I's in the front.
I like that idea. Let's keep it alphabetical. Let's also, while we're at it, keep the pluses first. Okay. So y1 z2 minus z1 y2. That sounds like it's easy to remember.
Yeah.
That's going to be our I vector. All right, we're just combining like terms. We have this many I's and we have this many I's, and we're just combining them to get the total I's. J, we're going to have where is it? J, we're going to have z1 x2 minus x1 z2. Can I do something real quick? Do you mind if I hear me out? I'm going to factor this -1 out. And I'm going to do x1 z2 minus z1 x2.
Okay.
Let me make sure I got that one right. Yeah, and the reason why I'm going to pull the negative out, I like to keep it alphabetical more than I like to keep it positive and negative. Wow. YZ, ZY, XZ, ZX. I want that first term to be alphabetical, and I think you'll appreciate it later. Okay. And this last one, I think it's still going to be alphabetical. It's our K vector. If anyone needed a reason why I's, J's, and K's are useful, here's an example. Okay, it's x1, y2. And we're keeping it alphabetical. y1, x2. Boom.
It's almost like you would want to organize it maybe in some sort of like grid or something.
Let's do it.
Okay.
Let me zoom in real close so we can like use all this nice white space. Right. Oh, look at that. We're doing a topic that is normally taught in calculus. Oops. So I'm going to do these little bars, organize myself.
Oh, interesting. Yeah.
Yeah. So I keep everything contained. All right. All joking aside, because you can't really like joke your way through this. I'm going to create something called a determinant. We've seen that word before, and it's in a completely new context, and it's very hand wavy, but it is going to be an algorithm that will A, give us the cross product of two vectors, and B, be readdressed at a later date. What I'm going to do is I'm going to have a 3x3 grid. And in my first row, I'm going to put the 3 unit vectors. In my second row, I'm going to put my first vector, and in order matters. A cross B is not the same as B cross A. They're off by a negative sign. So if you don't put the first vector in the second row, if you put the second vector in the first, you'll get a different answer. And then x2, y2, z2. And then if we do an algorithm called taking the determinant of a 3x3 matrix, a lot of jargon there. If we just do the algorithm, we will get the cross product. Mrs. Contreras, do you remember how to do it?
Yeah. If there's a few ways to do it. We can like be very fancy and use the vocabulary of like make a like cofactor expansion.
Let's not do that.
Okay. So
they will hear those vocabulary words later.
Or they can look over at my YouTube channel. There's a playlist on this.
We'll drop it in. We'll drop the link in the chat.
We don't have to. It's okay.
In the chat. I mean, in the description.
In the chat.
Okay.
So yeah, we're not live streaming this. So we have we can take our column I and our column J and just copy them over.
Our column I and our column J and copy them over. What do you want me to do?
Mm-hmm.
Can you do it?
I gotta zoom in. Or do you want to do like I times y1 z2 minus?
That's what I was gonna do.
Okay, yeah, that's fine.
Should we just do that?
Sure. You can watch my video for if you wanted another way of doing this.
Yeah. All right, so we're gonna kind of like expand along this top row. We are going to eliminate the I row and column, and we're left with a little tiny box. And we're going to take the product of the backslash diagonal and subtract the forward slash diagonal, meaning we're going to take y1 z2 and subtract z1 y2. Sorry. Are you doing it?
Yeah.
Oh, ooh, okay, cool. And then that was for the I vector. And put a little I. Oh, and you got the I there already. Cool. It's in the front. Then for the J vector, we're going to do the exact same thing. We're going to be left with x1, z1, x2, z2. And we're going to do the exact same process.
Then we do it again with the K.
Yep. And one last one for K. We're left with this box right here. We're going to do x1, y2 minus y1, x2. Right. And with those boxes, we're going to do exactly that. We're going to take y1, z2 minus z1, y2.
And I'm sorry, I lost my mind for a moment.
And just to keep things alphabetical, we want to make that second one negative. Right. This is the reason why we're doing this, and we're not really justifying a ton, is because there's a lot of backstory and a lot of, I guess, what would you call it? Knowing information going in. There's like a word I'm just not remembering.
Prerequisites.
Yeah, there's a lot of prerequisites for this. We're not digging into it too much, but we definitely encourage you to dig into it yourself or wait until Precalc C to get the rundown. But y1 z2 minus z1 y2, and this little algorithm will pump out the cross product. Right, all that legwork we did earlier is the cross product, and we're just introducing a way to quickly be able to evaluate it. It's not very quick, but there's no real fast way to evaluate it unless you're using a computer.
MATLAB.
Yeah, MATLAB will do it in a fraction of a millisecond. But if you're doing it by hand like us crazy people, then boom. This is the cross product. Oh, we had a whole spot on the next page to write it. Let's drag down.
Can we do that?
I think. What?
Can
I copy? Can I copy? I can copy.
There you go. Oh, you can copy stuff someone else wrote. That's awesome.
That's really awesome, but it's not fitting. Oh, I think I can
Less
change.
awesome.
Oh man. Oh man. Doesn't fit. I don't like that at all. Boo. Well, that's really unfortunate. So, but it's right up here. But that is a formula. That is a little algorithm to calculate the cross product. It's kind of annoying, but it does what we need it to do. Let's do it once.
Okay.
6, -3, 3 cross 4, 9, -7. Let's create this little box. What do I put in the top row, Mrs. Contreras?
I'm just kidding.
What?
I'm just kidding.
Oh, I like that so much. I was like, what are you talking about? And then I understood. IJK. I'm just kidding. What a great mnemonic device. Although it's just 3 letters. So I don't know if you really need it. What goes in the second row? And it matters.
The first vector. So 6, -3, 3.
Yeah, if you put the 4, 9, -7 first and the 6, -3, 3 second, you'd get the same vector, but negated because of the right-hand rule. And then 4, 9, -7.
Mm-hmm.
Right. So let's see. Is this called a minor? I can't remember the vocabulary.
Submatrix.
Submatrix. What is the determinant? What is that little product minus product of the leftover submatrix?
21 minus 27, so -6.
-6. I. All right, I'm not going to forget this negative here. Boom, boom, boom. And while I'm at it, I'm going to go ahead and throw some parentheses for the that vector too. I'm going to kind of cross out those. I'm left with 6, 3, 4, -7. What's the determinant of that submatrix?
So -42 minus 12, which is -54.
Times -1, positive 54J. And eventually we can convert this to a this matrix, this vector, sorry. And then last but not least, little cross 6, 9, and -3, 4.
So that's 54 plus 12.
That's the sneaky thing is when the most people who get these problems wrong, not because they don't know how to do it, it's because the negatives sneak up and get you.
Mm.
You said 54 plus 12, which is 66.
Yep.
All right, let's verify that this is perpendicular to the given vectors. Okay. When are 2 vectors perpendicular?
When their dot product is 0.
When the dot product is 0. So I'm just, for the sake of writing it, this is U, this is V. Is U dot the cross product, let's call this W, is UW 0? Right.
That's what? -36.
-3 and 54 is 100 and 150 and 12, 162. And it's going to be -162. And then the 3 and 66, 180, 198. I got a good feeling about this.
Looks good.
Yeah, -36, -162. That is -198 plus 198 is equal to 0. And we'll leave it as an exercise to verify the other one. Boom.
Sounds good.
Let's keep it moving. All right. But if you don't believe us, prove it to yourself. And if you do believe us, awesome. We have found a vector that is perpendicular to the both of the original vectors. And if we wanted to, we could take the magnitude and verify that it's also u v sine theta. But we'll leave that as an exercise as well. All right. Here's a way we can use the cross product to do something completely not vector related. Write the Cartesian equation, no vectors, the Cartesian equation. AX plus BY plus CZ plus D is equal to 0. Write the Cartesian equation of the plane that contains these 3 points. What are you feeling?
We need at least one vector, maybe two.
Okay,
Should we go from A to B?
let's go from A to B. All right, so we got this vector in the plane. What do we need to define a plane? Remember from last video lesson?
We need a vector of like where we're starting and then a direction vector.
Well, you're thinking of the vector equation of a plane. We want the Cartesian equation of a plane. Do you remember how we defined it?
There was some stuff with multiplying the components of a vector and then like the dot product.
So we have a vector, and there is a unique plane that is both perpendicular to it and goes through the tail end of the vector. We need a normal vector to this plane. We need a vector that is perpendicular to this plane. Then we're in business. We have points in the plane. We just need a vector perpendicular to this plane. How can we get a vector perpendicular to this plane?
Maybe we should use the cross product.
I think so. How can we use the cross product though to get a vector perpendicular to this plane? What does the cross product produce?
The normal that is in the direction of following the right hand rule.
And so if we look at like AB, the vector AB, which is going to be -3, 0 minus 3, 2 minus 1, which is 1, and -4 minus 4, -8. If we take that vector and we cross it with AC, so 5 minus 3, 2, -2 minus 1, -3, -7 minus 4, -11. If we cross those two, we're going to get a vector. I'm going to take my hand, point in the direction of AB, curl it in the direction of AC, and we're going to get a vector that is perpendicular to both. That is the thing we need to define the plane, a vector perpendicular to the plane. That vector is perpendicular to the plane because it's perpendicular to two vectors inside of it. AB cross AC gives us, I'm going to call this vector here the normal vector. If you want one pointing the other direction, we just do AC cross AB.
Or just negate it.
All right, so let's do it. I don't think it's going to take too long. I, J, K. I'm just kidding. -3, 1, -8, 2, -3, -11. We're going to get an I minus something J plus something K.
So it's -11 plus 24, minus 24.
Yeah, those negatives will get you, man. All right, how about you do the K, I'll do the J to speed things up. Is that cool?
I'm doing K.
Yeah.
Okay.
Ooh, I almost messed up. That'll get you. I'm telling you. 33. The sound of math. All right, we now have a vector that is perpendicular to our plane. So how do I then get the equation of the plane? Think about the definition of the equation of the plane now.
We need a point on the plane, which is any of those 3 points.
Any of those, yeah. Or we can use yeah. So we're gonna dot our perpendicular vector with. Oh no, I want to do what you did last time. I'm gonna use our normal vector. That's going to be our coefficients. Minus is it minus? Yeah, minus 49y plus 7z plus d is equal to 0. We are dotting our perpendicular vector with some vector in the plane. Now, which point do you want to plug in to find d?
Well, I like the one that has 0 in it, so let's use B.
0 to negative 4. 0 to negative 4. And then what do we get? Negative 96 minus
98.
You're right. Totally right. And then minus 28 plus d is equal to 0. D is going to be the opposite of the sum of those two things. 98, 106, 126.
Yeah.
Boom. So we jump back up. We can turn this into a 126. And this might simplify. I mean, there might be a 7 totally goes into 35 and 49 and 7. I don't know if it goes into 126 though.
It does because we got it from 49 and 7.
So we could divide this equation probably by 7.
Yeah.
Negative 5x minus 7y plus z. What's 126 divided by 7?
14
This,
minus 14 and 18.
I'm gonna go ahead and say yes. Boom. So these are the same thing. There's multiples of each other. It's like how y equals 2x plus 6 is the same as 2y equals 4x plus 12. Like the same thing. There's just a different scalar. Boom.
Cool.
All right. One last problem here. And we can just talk it out. We don't have to do this one. I don't think we need to do another cross product. But how can we use the cross product to find the area of a triangle?
Well, what's the area of a triangle? It's like 1/2 base times height.
Let me draw a triangle. The area of a triangle is 1/2 base times height. All right, so like let's say we have a side A, B, and C. The base here is B. I'm actually gonna write this. I'm gonna write out the words base. Base times height. The base here is B. What's the height?
Well, it's perpendicular to B.
Need some dotted lines.
Mm-hmm.
I'm gonna throw a theta there. What's the height in terms of theta? And given information A, B, and C.
We should trig.
Trig. The
Yeah.
height is, or more specifically, height over A is equal to sine theta.
Mm-hmm.
Sine theta is equal to opposite over hypotenuse. The height is A sine theta. So I'm going to go ahead and do a little bit of rearranging. 1/2 AB sine C. We've seen this formula before. AB sine theta. What does that look like? Specifically this thing right here.
That looks like the cross product.
That's the definition of the cross product. Torque. Like if we can figure out how long B is and how long A is, then if we just do the cross product and we hit the magnitude, we'll have, I guess, the area of a parallelogram.
So like, can I sketch in a parallelogram here?
Are you doing it?
Rather poorly, but yes.
Yes. We take advantage of the moving the yeah, that could have been better. I'm gonna be honest.
Because my screen got cut off.
So if you're given the 3 vertices of a triangle, all we need to do is find 2 vectors that compose that triangle and then take the cross product divided by 2. We could look at like AB cross AC. That's going to give you a vector of which its magnitude is the length of AB times the length of AC. If we cut that in half, we have the area of the triangle.
So then we also have like a cool way of figuring out what the area of a parallelogram is.
Mm-hmm. Which is actually, and let's not ruin too much, but that process we did earlier, finding the determinant of a matrix, it has a relationship to the area of a parallelogram as well.
And if you want to get really exciting, then think about R3 and what would 3 different vectors give you? Like if you were thinking about projecting them, might get something like a parallel pipette.
Parallel pipette.
You could find like the volume of it or something. Might be cool. I don't know.
Might be cool. Might be volume, you know. My voice is cracked. Volume, area, vectors. All right, we're wrapping this up, but I'm kind of sad because I love vectors and I wish we could do more, but if you learned everything now, you'd have nothing to learn later. So we're going to move on from vectors after this video, and we're going to jump into what's next? Polar. I love polar. I just really like all the units that happen at the end of Precalc B. But it's been a great time doing vectors. Any thoughts, words of wisdoms? Anything you want to wrap this unit up with?
Wrapped up the vectors unit? I don't know. I think just wearing Eagles gear makes me remember how it's okay to learn to live with disappointment.
But also
if your team is bad, it's okay.
But also hope for a better future.
Yep. Mm-hmm.
I don't know how many teams can say they've won a Super Bowl in the past 10 years. Less than 10.
That's true.
All right, let's close this one out.